Welcome back to Math with ACE. We are focusing on statistics again, and we are dealing with hypothesis testing and drawing conclusions. In a hypothesis test, you first need to set up your hypotheses to determine the claim that you're testing. And once you've decided the claim that you're testing, you can then go on to check your conditions before you do any calculations to make sure it's appropriate to run these numbers. And then finally, once you've run the numbers, after you've checked your conditions and your set up hypotheses, you analyze the probability that you calculated based on your test statistic and use that to make a statement. So remember, what we're doing is we have these claims. We have one-tailed tests and two-tailed tests. I'm going to use, let's say, means for this. We have some hypothesized value that we're assuming across the board. And then we could wonder if it's less than that hypothesized value. We could wonder if it's more, or we could wonder if it's different. And all that's saying is things like, Lay's says that they put 12 ounces of chips in their bags, and you think that it's less than 12 ounces. Or Lay's claims that there's, 2% of air, not averages here, but like 2% of air in bags, and you think it's more than that. Or Lay's claims that their bags have 12 ounces of chips in it, and you think it's different than that. Different means it could be less than that or more than that. It's just testing their claim or testing a claim of, I don't think it's what they say it is. The way that your claim is stated, we are looking for evidence like that, which means we're looking for evidence in that direction. So we calculate this test statistic. Let me get my curve good. I'm going to bring my line up. We assume this hypothesized value, and then we calculate a test statistic based on that. And then we calculate the probability of obtaining that test statistic and see how likely it is. So our rejection region only occurs to the left. In a test where you're talking about being greater than, you have your hypothesized value, but then you are calculating the probability greater than, because that's the only thing I care about, is how likely it was to be greater than that value. In a hypothesis test that is two-tailed, you could be greater or less than. It doesn't matter. You're not going to do both at the same time. It's going to be based on the sign of your test statistic. So I could reject here or here. And this is the rejection region here. And this is the rejection region here. Now, you can calculate a critical value that is going to be your rejection value. There's ways to compare your hypothesis test. We use a p-value hypothesis with a critical level or with a level of significance. Some people use a critical value approach. We're going to stick to using just the p-value probability. So what we have to do is we calculate the probability of obtaining the sample data that we did, or data more extreme, assuming the null is true, and then we use that to help us make a conclusion. Is it small enough or not? How likely was your probability? So you have to determine what's your baseline. What is your cutoff? What probability do you need it to be convincing for you? I always ask my students in class, okay, I baked cookies and I'm, 95% confident that they're not going to kill you, which means 5% of the time it's going to kill you. Is that enough? Do you need it to be a smaller percentage, right? How likely are you to make an error? Do you need it to be 1%? Do you need it to be 0.1%? It's a very terrible example, but you get the idea of what the level of significance is. Now, in our class, remember, we have this arbitrary 5% that we're using, but it's really dependent on what you're dealing with and what the consequences of your error are as to what level of significance you should be using. So if you're in medical trials and one consequence of error is death, then you need that level of significance to be very, very small so that your probability is very, very small. You don't want to have that probability of committing a type 1 error to be large, because you don't want that to occur, and you don't want that possibility out there. So you have this level of significance, which we call alpha, which is the probability of committing a type 1 error, and it varies dependent on the problem. If we aren't given one in our class, we're going to use this arbitrary 0.05. Or in my class, I should say. So what do I do with that? Well, that is our stop line of once it gets less than that, then I think that there's evidence for the alternative. There's evidence for the claim. So if the probability of obtaining the sample data that we did purely by chance is very large, means it happens a lot, that means our null might be a safe assumption and we don't have evidence for our claim. But if the probability of obtaining the sample data that we did is very small, then our assumption is probably wrong and we have evidence for our claim. So what we do is we compare our p-value to our alpha level, and we use that to help us. Now, we always make a decision about the null hypothesis, and we always have evidence about the alternative hypothesis. So you are rejecting or failing to reject about the null only. And you have evidence or no evidence about the alternative only. Remember, we don't prove someone innocent, so we're not saying that we have evidence for the null. No, we either reject the idea or reject our assumption or not, and then we have evidence or not for our claim. So if your probability is small compared to your alpha, so if your probability is small compared to whatever our level of significance is going to be, then we reject the null and have evidence for the alternative. If the p-value is not small, then we don't have evidence, so we're not going to reject the null. If the p-value is low, reject the HO. Okay. If the p-value is not low, then you don't reject the HO. And reject always means if you're rejecting the first thing, then we're always saying we have evidence for the second thing. If we don't reject the first thing, we don't have evidence. So don't and don't, do and do. Okay. Now, let us put it all together, add some context in, and do the whole thing.